Hello, friends. It's your guy, it's your dude, it's your man, it's your buddy, the knick-knack, cardiac attack, patty whack, Raptus, here to show you the way to do part number 2 of the thumbnail grid that's going to blow your lid and shouldn't stay hid. You can find the repository link in the video description. You can also find a link to the previous and next tutorial as well as the final project. Like, subscribe, and share with your friends. Follow along for the best results. So last time, you'll recall, we finished with this custom cool 2D grid using our own custom layout scheme and our own custom view builder. That's cool, but today is going to blow that away. So today we are going to start boning out our mock web service. The backend database is going to be essentially a giant list of emojis. Once we load the data models, they're going to be shown on the cells. If you saw the final version they download individually, we're not going to do that yet. So it's just going to be loading or loaded. We're going to implement range fetch on our web service. This is how most enterprise backend data model web services work. You have essentially an index and a count. We're going to keep track of which cells are visible on screen based on the inner and outer geometries of the scroll view, or in our case, list. Finally, we're going to implement smart fetching based on which cells are visible on the screen. And you can see them getting clipped a little bit before the top and bottom. This is intentional to illustrate the clipping is happening, and so that we can visually confirm that. So that's basically it. Let's dive into it and let's go ahead and start cranking out our fake web service. So I'm going to go to my page model and let's build our database. So I'm just going to say private let all emojis equal. You can use your own giant string of emojis, or you can find this one in the video description. Next, I'll build a fetch function that takes into consideration that index and count. So just func fetch at index int, and then with count, also an int. So we're going to want a completion handler here, and we're going to want to give it a way to fail. So let's build our own custom type of error, and I'm going to call this service error. So I'm going to make an enum service error, and that is going to adopt the error protocol, and I'm going to give it one bare bones case of any. So now for the completion handler, I'm just going to say completion. This is going to finish on a different thread, so I'm going to make it escaping, and I'm going to make it a something to void. But this something is going to be the Swift result type, and for the success case, we'll use void. For the failure case, we have our service error. So that's great. After we successfully fetch, we're expecting to see kind of a list of models. So let's just build our model for our data. This would usually be obtained through JSON parsing or something of that nature. I'm going to go File, New, Swift file, and I'm just going to call this thumb model. There's no reason not to make this a struct. I'm going to say struct thumb model, and I'm just going to give it two member variables, index. Remember, everything we do is index based. And then I'll give it image, which is just going to be that emoji, so I'll make it a string. I'm going to drag this up to the top and go back to the model. So we have a kind of scheme where we have data, data, blank, 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 data, if we happen to scroll way down and start a fetch. So that sounds a lot like some and none. So that means it's a great candidate for optional. So I'm going to give us an optional array to represent our loaded models. So I'm going to say var thumb model list equals array of optional thumb models. And really, I want to protect this and make sure nobody else writes to it or anything of that nature. So I'm going to make this private and expose a little function to pull something out of it. So I'm going to say func thumb model at index, and that will return an optional thumb model. So I will now just make sure we're in range. So if index greater than or equal to 0 and index is less than thumb model list.count, return thumb model list index. And by default, since we're doing optional, we have the choice to return nil, or the option to return nil. Let's go ahead and fill in our fetch function. So remember, this is a simulated web service. So let's just jump to a background thread or background queue, global QoS background. We'll go asynchronously on it. And then let's just sleep to simulate network activity. Thread.sleep for time interval. I'll do time interval dot random from 0.25 to 2.5. Those are seconds. Then let's just make a rule that all of our network services finish on the main thread. So I'm going to say dispatch queue.main.async. And finally, let's just assume we always succeed. So I'm going to say completion with the success case and put a little void in there. So what do we want to do when we do successfully fetch? We want to fill in this list of thumb models. So let's just build another function, another helper function, private func simulate range fetch complete. And it's going to be the same at index with count. So I'm just going to paste those in there. And this function is going to be mutating, since we're a struct right now for the model. So in order to avoid that, because we're going to call it again here, self.simulate range fetch at our index with our count. This is a great time to go ahead and instead of having a mutating function that later calls another mutating function, let's just go ahead and make this be a class. It is now a better candidate for class. We don't want that kind of mutating structure. Beautiful. We are looking good now. So let's fill in our simulate range fetch complete. And in order to simulate that, we've got to remember that we could be at the end of the range. We could have something like exists, doesn't exist, and then we want to fill in stuff there. So for that case, I'm just going to say let new capacity equal index plus count. Then I'm going to say while thumbModelList.count is less than new capacity, thumbModelList.append nil. Then let's kind of build our loop. We're going to go and fill in those indexes. So I'm just going to say var index equals index, and while index is less than new capacity, something, obviously index plus equals 1. In order to create one of these thumb models, we need to pluck out our emoji, such as the sailboat or the mousey. So that's a string. We're going to have to make it into an array of characters. So let emojis array equal an array from all emojis. Now we can do it. So I'm going to say let new model equal thumbModel. The index is going to be index. The image is going to be emojis array at our index, but that wrapped in a string. Emojis array is an array of characters. Then we can stick it in. So thumbModelList index equals new model. Let's see what we can do to improve this, because I think we could be out of range. We could be feeding this weird numbers. Let's assume that we might. So if this new capacity is like to the left of 0, obviously we can't fill anything in there. So if new capacity is less than or equal to 0, I'm going to return. Then just to mix it up, I'm going to say guard count is greater than 0, else return. Then I'm going to say guard index is less than all emojis dot count, else return. And I don't want the count to be too big. So if count is greater than something absurd, 8192, I want to return. So that's most of our outside cases, and it's better to be too safe than not safe enough, as long as we're not illogical. Now, we could still be fetching from -5 to, well past the end of the array. So really, we want to make sure we're in range down here, too. So if index is greater than or equal to 0, and index is less than emojis array.count, we'll do this. One other thing to check is, does our model already exist? Because if it does, it's very possible that we're operating on it. So I'm going to say if thumbModelList index equals nil, then we create the new model. We can go ahead and combine these two if statements. So I'm going to put thumbModelList index equals nil on the same line as my first if statement, and we can make a little bit more of a compact code that way. And I'm going to compact even the bottom and this space. Then I suppose I'll delete that comment. And I'm going to go ahead and make one more function now, which is clear. So I'm just going to say func clear. And all that's going to do is thumb model list dot remove all. Beautiful. Now we are rocking and rolling. So let's go ahead and migrate some of this stuff over to the view model, such as our thumb model function. I'm just going to copy that signature, go to the view model. Remember, the view model is kind of a gatekeeper. So I've just pasted that here, and I'm just going to pass it forward. So I'm going to return model.thumbModel at our index. I'm going to do the same thing for clear. I'm going to copy the signature for clear from my page model into my page view model. And I'm just going to say model.clear. And then back into my page model. The big one, fetch. So I'm going to copy the signature from fetch from my page model into my page view model. There we go. And this one is going to be more complicated because we want to do stuff with UI. But let's just make the skeleton. So we're going to do model.fetch at index count. The completion, we don't want to just pass. We want to actually use the model's completion handler, and we want to respond appropriately to that. So let's go ahead now and have a way to know if we're fetching that we can know about internally and the outside world can peek in on. So I'm going to say private set var is fetching equals false. Then in fetch, I'm just going to say is fetching equals true. But I'm going to even make sure we're not currently fetching. So if is fetching return. And then I'm going to switch on this result from our model's fetch function. And while I wait for Xcode to discover this, there it goes, I'm going to go ahead and use this autofix. So we've got two cases, success and failure. We don't need those parentheses. And for failure, let's say let error. In both cases, I'm going to say self.isFetching equals false and call the completion handler. In this case is success. And that takes a void. In this case, I'm going to say self.isFetching equals false and completion.failure and pass in error. The other thing that I think we want to do is tell the view to draw or redraw or refresh in both of these cases. And I'm replicating a lot of this code in both cases. I think that's okay because order really matters in this type of thing. So self.object.change.send in both cases. Let's go ahead and call that function. So I'm going to make an init, and we want to just go fetch at, I'm going to say 4 so we can see some of the weird corner cases we get. For the count, I'm just going to make up a rule right now that we always fetch the exact same number of elements. So I'm going to say private static let fetch count equal 6. And the count is going to be fetch count. And for the completion here, we really don't care. Great. Awesome. Now, let's build a little view that can replace that Z-stack to show different cases for our model. So I'm going to say new file, and this is going to be a SwiftUI view. So I'm going to make this be thumb view. So thumb view is going to work with thumb model. So I'm just going to say let thumb model be an optional thumb model. I'm also going to give it a width and a height. And I put the width and height in here so that we can size before we apply the background. We can do dot frame and then dot background. So a little bit weird. For the preview, we're gonna have to go back to thumb model and add one of our mocks. So static func mock returns thumb model, and this is just going to return a thumb model. The index can be 0. For the image, let's just pick out an emoji from edit emojis and symbols, and I'm going to go with the petri dish. Back in thumb view, I'm going to drag this to the top. For the preview, I can just say thumb model.mock. For the width, I'm just going to phone in a number, maybe 100. For the height, I'll say 140. Now for the body, I would love to be able to say, show me one thing if we do have a thumb model, otherwise show me something else. So I'm going to say if let thumb model equal thumb model, do something, otherwise do something else. So I'm going to make 2 little helper functions. One will be private func thumb content. That will take thumb model as a non-optional thumb model and return some view. And this is just going to be a Z-stack. I'm going to make the other one private func placeholder content, returning some view. The compiler will figure out its type, and I'm just going to return a Z-stack. Now I can go ahead and fill these in the body. So in this case, I can do thumb content with thumb model, and in this case I can do placeholder content. Since this body returns something that isn't wrapped, it's best to make this be a view builder. So for both of these, I think we want to have that rounded rectangle background. So I'm going to make that shape a private static let tile background equals rounded rectangle, the corner radius of 12. So I'm just going to say dot frame. We have the width, we have the height. We're going to keep the default alignment, then dot background, self dot tile background, dot fill, dot foreground color. I'll make this one be orange, and I'm even going to make it a bit faint, so opacity 0.5. I'm going to copy these two modifiers into placeholder content and change only orange to purple. So for the thumb content, we want to show that emoji. So I'm going to say text, and this is going to be thumb model dot image, and I'm going to make the font be a system font of size. Let's make it width times 0.5. Won't be a fixed size, it'll be sized to half the width, approximately. This is a font size, so it works though. So for placeholder content, we can just do a progress view, which is like one of those loading spinners with a progress view style of circular progress view style. Now let's do the one with tint, and let's make it white. Beautiful. Let's go now into my page view, and let's actually get these things showing up. So instead of this Z stack, we can now put a thumb view. And here are our arguments. Thumb model, we can just get from the view model. So view model dot thumb model at cell model dot index. Width and height we already have. It's layout dot get width at cell model dot index, and the height is layout dot get height at cell model dot index. This replaces our Z stack. And that should be good enough to give us something we can see. Let's take a look. Cool. So we saw our 6 cells load, and we see these other ones are in the loading state. Awesome. All right. Now it's time to start considering which cells are visible or not visible. And that is going to be based on where we scroll to. So let's jump back into grid layout. We'll delegate that task to grid layout. So similar to how we register our container, let's go ahead and make another function to register scroll content, and we'll take as an argument scroll content geometry, and that will be a geometry proxy. And similar to how we have container frame, let's make another one, private var scroll content frame, start at 0, and let's go ahead and say let new scroll content frame equal scroll content geometry dot frame in global, and we'll just assign this. So scroll content frame equals new scroll content frame. So that's registering it. We also kind of want to handle it, or at least, process it in some way. So I'm going to make private func handle scroll content did change position, and I'm going to take as arguments container frame and scroll content frame. And for now, I'm just going to go ahead and print the tops of these frames so we can see them change while we scroll. This is a bit of a weird step, so I'd like to test this real quick. So I'll say print container y equals container frame dot min y, and then content y equals, and I'll do scroll content frame dot min y. And I'm just going to call that function when we register our scroll content. So handle scroll content did change position with our container frame and our scroll content frame. Let's go back to my page view, and in the same way that we are doing this register, let's go up to grid where we have scroll content geometry, and we want to register the scroll content position before we get all visible cells. So scrolling might impact which cells are visible. So I'm going to say layout.register scroll content geometry. Let's run it and check out the printout. So there we go. Container Y, content Y. They're both 47, and this is due to the safe area. We're gonna have to accommodate that in a second, but let's look at it changing. Cool. So the content Y changes as we move around, and that gives us the ammunition we need to properly clip. Beautiful. We are becoming more and more powerful. Let's go back to grid layout, and let's go ahead and kill this print statement. We don't need it anymore. And now is the time to address this issue with the safe area. And this is kind of a pain in the butt, but let's do it anyway. We're gonna need it at the end of the day. So we have container frame, and I'm gonna copy that and make another copy. We really want two versions of container frame, and I'm gonna be very verbose about what they each are. So this is container frame inset by safe area, and this is container frame without safe area. Then when we register container, let's check both of these frames. Don't worry about the errors for now. We're going to fix them all once we have these two versions. So I'm going to just grab all four insets and assign them to separate variables just to keep our code on shorter lines. I'm say let left equal container geometry dot safe area insets dot leading. Let right equal container geometry dot safe area insets dot trailing. Let top equal container geometry dot safe area insets dot top, and then let bottom equal container geometry dot safe area insets dot bottom. And also, mostly just to keep it more concise, I'm going to define the left, right, x, and y of the expanded frame. So I'm going to say let expanded x equal. And this new container frame is really the one that is inset by safe area. So I'm going to rename that now to be more clear. So this is new container frame inset by safe area. So this expanded x is going to be new container frame inset by safe area dot min x minus left. These are all positive numbers, so to remove the effect of the safe area, we need to subtract from the left and top and add both to the width and the height. So I'm going to say let expanded y equal new container frame inset by safe area dot min y minus top. Then let expanded height equal new container frame inset by safe area dot height plus top plus bottom. Then let expanded width equal new container frame inset by safe area dot width plus left plus right. Alright, so now we want our container frame without safe area. I'm going to say let new container frame without safe area equals a CG rect. I'm going to do the case with 4 CG floats, and I'm going to put them all on separate lines. I told you this was going to be a pain. So we've got all the variables to plug in. This is just expanded x, expanded y, expanded width, and expanded height. So let's break this up into separate lines. I'm going to copy and paste new container frame not equal to container frame or, and have that twice. So we want both of these versions of container frame. And if either changed, we're going to consider it to be that we need to relay out. So this is going to be inset by safe area and inset by safe area. This is going to be without safe area and without safe area. I know it's getting kind of hard to read, but pause it if you need to. I'm going to copy and paste this line, container frame equals new container frame, and it's going to be the same thing. One is inset by safe area, inset by safe area. This is without safe area and without safe area. and I'm just going to compress all this. And now I'm going to go one by one and logically choose which one it should be. So the scroll content did change position. We're going to use this for clipping. I'm going to say use for clipping, show and hide cells, notify which cells are visible. So because we're using it for clipping, we want this to be without safe area. When we lay out the grid, the system is already factoring in the safe area. So our width really should be inset by the safe area. When we calculate the number of columns, this again is our space to lay stuff out. We're already gonna be inset by the safe area. Same here, container frame, we're gonna be inset by safe area. So I'm just gonna print out both of these real quick. I'm just gonna say container frame inset by safe area equals that, and container frame without safe area equals that. And I'm gonna run it and make sure that it looks good and see what those numbers look like. Okay, you can see that without the safe area, we have no top and we are taller. And everything still looks correct, so it seems like we picked the right numbers in all of those cases. I'm going to go ahead and rotate it, and we can see that again we got this, now we have the safe area in the X dimension, and we have a shorter width. So basically it worked, and we can see it's still laid out correctly, and now we're going to be able to correctly clip. Wunderbar. Glorious. Now let's go ahead and add some internal storage so we can know what's visible or not, and we'll fill it in after we've got the storage allocated. So in the same way that we have these other arrays, I'm going to make two, one for rows and one for cells. Sometimes it's pertinent to access it by cell, and sometimes it's pertinent to access it by row. So I'm just going to make both, which is theoretically having two sources of truth, but it makes sense in this case, and I think it is worth it for the speed. So I'm going to say private var row visible array is an array of bools, and private var cell visible array is an array of bools. Then I'm going to jump down to our layout helpers and go all the way to the bottom, and I'm just going to make another func build visibility arrays, And I'm just going to reallocate the space if it's a different size. So for example, if row visibility arrays count is not equal to the number of rows, then row visibility array equals a new array of bools. Repeating, you can make them all false with the count of number of rows. For the number of cells, we don't want to use the number of elements because we don't want to consider the case where we have a row, namely the bottom row, with less elements than all the other rows. So I'll say let number of cells equal number of rows times number of columns. Then if cell visible arrays count is not equal to the number of cells, cell visible array equals an array of booleans, repeating false with the count of number of cells. Let's go ahead and compress this. And where can we call it? We'll call it in our layout grid function. So build visibility arrays. I'm going to go ahead and get rid of this print statement. Beautiful. Now we've got our arrays boned out. Let's go ahead and try to fill them in. So whenever the scroll content changes position, we want to essentially see which rows are visible and which rows aren't visible. And we have all the data we need to do it, which is this content frame, this container frame, and then the frame for each cell. So try to follow along. I know it's a bit of a reach, but there's nothing that complicated going on. So we kind of need a loop through all of our rows. So I'm just going to say for row index in 0, 2, the number of rows, do something. And we want to see if the container y range adjusted by scroll offset. So I'm gonna make these all 0 for now, but I'm gonna bone out what I want to be able to compare. So I'll say let container top equal 0 and let container bottom equal 0. And then this is going to be the row y range. So let row top equal 0 and let row bottom equal 0. So do these overlap? We can build little ranges. So I can say let container range equal container top to container bottom, and let row range equal row top to row bottom. Then we can use Swift's built-in overlap and say let overlap equals container range dot overlaps row range. Then if overlap, we are visible. Otherwise, we are off screen. So what are we going to do in either of these cases? Let's just print. This is kind of a reach. Let's see if we get something that kind of makes sense. So I only want to flag us as newly visible. If we just became visible, this is going to get called a lot. So I'm going to say if row visible array row index equals false, then row visible array row index equals true. And I'm going to print row index is now visible. And in the other case, I'm going to say if row visible array row index equals true, meaning it was visible, but now it's invisible, then row visible array row index equals false. And I'm just going to copy and paste this print statement, but make it be invisible. I'm going to go ahead and compress this. So how can we fill in the right values for these zeros? Well, I think the row is going to be pretty easy because we have the Y values for all the cells. So really that's just cell Y array at row index. And the bottom is just going to be row top plus cell height. So that's kind of easy. The container is also going to be easy, but it's a little bit tricky if you're not sure how to flip the signs. But basically, we want to adjust our container frame by the scroll content, and we really want to subtract the scroll content from the container frame. So the top is going to be container frame dot min y minus scroll content frame dot min y. And we're doing integers, so I'm going to make everything be an integer. So likewise, container bottom is going to be an integer. Container frame dot max y minus scroll content frame dot min y. So we shift both by the min y. Let's see if it works. Let's see if we get a printout. Cool. That looks promising so far. So all of these rows became visible. And we can see some of the higher rows at the lower indices becoming invisible. It looks like it works. Groovy. Dynamic. We are on fire. Now let's get it so we can actually see the rows becoming visible and invisible. And in order to do that, we can't really clip right at the exact top and bottom of the screen. We want to make this something we can adjust anyway, but I'm going to say private static let on screen padding. And I'm going to make it a negative number so we clip within the screen. And the container top, I'm just going to subtract on screen padding. And to the container bottom, I'm just going to add on-screen padding. So that's cool. And we have our row visible, but what we'd really love is inside of this get all visible cell models to be able to factor in if the cell is visible. So I would love to say if, and I'll just add the safety check now, if index is less than cell visible array count and cell visible array index. Then we add that model. And I'm going to go ahead and compress this all and shift this over. All right. So how do we fill in the cell visible array? Well, we kind of need some more helper functions to convert from a row index to, I guess, the first cell index of that row and the last cell index of that row. So let's build exactly those helper functions. So func first cell index of, and I'll say row index, int returning int. This is basically going to be the row index times the number of columns. So I'm just going to say number of columns times row index. Then we want last, so func last cell index of row index int returning int. It's going to be almost the same thing. So number of columns times row index plus number of columns minus 1. And I'm going to go ahead and put this in parentheses too. So now that we have those, let's go up to our scroll content did change position. Let's just go ahead and grab those two values. So let's say let first cell index equal first cell index of row, and we have row index, and let last cell index equal last cell index of row index, and we'll just loop inside of these if statements. So for cell index in first cell index all the way to last cell index, I'll just say cell visible array cell index equals true. And I'm just going to copy this loop, and in the off-screen case or the invisible case, right inside of that if statement, I'm going to paste it, but I'm going to change this visible to false. And that should be everything we need to actually see the cells getting clipped. Let's have a look. Yeah, you can see that cell coming on screen at the bottom, and you can see at the top it's coming in and out of sight. So we're clipping as we scroll. That's what we wanted to see. Beautiful. So now I'm going to give grid layout a way to communicate this information back to my page view model. So I'm going to just get rid of these comments, and I'm going to make a protocol called grid layout delegate, and I'm going to make two functions. So func cells did enter screen with a start index and an end index, and also func cells did leave screen with, again, a start index and an end index. We would love to make this weak, so let's make a delegate, and it's because my page view model owns grid layout that we want this to be weak. So if we say weak var delegate is a grid layout delegate optional, it's going to complain. We could either make this a class protocol, or we could do what they recommend, which is to make it an any object. Let's go ahead and go to my page view model, and let's make an extension where we can form. So extension my page view model, adopting grid layout delegate, and let's let the compiler or Xcode throw a fit and fix our error for us. So in either of these cases, what we're primarily concerned with on my page view model is potentially fetching more thumbs. So these are two cases where maybe we want a private func fetch more thumbs if necessary. And in both of these cases, let's just fetch more thumbs if necessary. And then let's set up the delegate. So on a init, I'm going to say layout.delegate equals self. Beautiful. We're looking good. So let's also just put some prints here, because we're going to do a couple weird things. So I'm just going to say cells entered screen, and I'm going to put the range, which is going to be start index to end index. And then for cells left screen, I've just copied and pasted and replaced entered with left. So we have these delegate methods, but we're not calling them. So let's jump back to grid layout and let's call them. So the obvious cases are both of these cases where a row becomes visible. So we can just say delegate dot cells did enter screen in this case, and we have the first cell index and the last cell index already. Same thing down here. We can say delegate cells did leave screen from first cell index to last cell index. There's one more weird case, because you remember when we build our visibility arrays, we just fill them up with false. So we're not really telling the delegate that all of those cells are hiding. So when we lay out the grid, we're going to go ahead and hide all the visible cells, and we're going to let the delegate know which cells we're hiding. This is going to create some weird behavior when we rotate, but ultimately it's the correct behavior. So I'm going to say private func hide all visible cells. And when we lay out the grid, before we do anything, I'm going to hide all the visible cells. So to hide all the visible cells, we can again loop through the rows. So row index in 0 to number of rows. And we really are only concerned with visible rows. So row visible array, row index is true. Then, of course, we're going to set that to false. Then we want to set the cells to false, and we want to tell the delegate that the cells left the screen. So I'm going to say let first cell index equal first cell index of row, our row index, and let last cell index equal last cell index of row, row index. Then I'm just going to loop through here. So for cell index in first cell index all the way to last cell index, I'm going to say cell visible array at cell index equals false. Then let's tell our delegate. We're going to say delegate dot cells did leave screen. Cells did leave screen from first cell index all the way to last cell index. So I'm going to build and run, and we should see some wacky printouts when we rotate. But if we try to match all the entered screens and left screens, they should be correct. Alright, so all of these cells entered the screen. As we scroll, we should start to see some leave the screen. Looks good. I'm going to clear that, and now I'm going to rotate. This is going to be very weird. So let's look at what happens. At the end, we can see that these cells, and those are the current cells that we see now, all entered the screen. But through the rotation, we had all the cells leave the screen, and then we have them entering and leaving the screen several times, which is kind of weird. But at the end, it's correct because all of our portrait ones did leave, and our landscape ones appear and leave several times. So it's weird, but that is necessary. I'm just going to rotate back and kill this. Beautiful. We are in great shape. We have slain the dragon. So let's go back to my page view model, and I'm going to get rid of these print statements now. But let's think about what we'd like to fetch more thumbs if necessary. Really, we need to know which cells are on screen. Those are the ones we want to fetch first. So which ones are on screen? It's essentially first cell index on screen to last cell index on screen. It's this range. So let's delegate this trifling responsibility to our grid layout, which is too big already, but as they say, the fat get fatter. So let's build a couple of little helper vars. So I'm going to say private var first cell index on screen started at 0, private var last cell index on screen, set it to 0. Then I'm going to go down to our helper functions, and I'm going to make a way for the world to read those from us. So func first cell index on screen returns an int, and let's just return our first cell index on screen. We don't need to compute this every time. Same for last cell index on screen returning an int. We can just return our last cell index on screen. So how will we compute it? We really only need to compute it when cells become visible or invisible. So I'm going to make a function func refresh first and last cell index on screen. And I'm just going to go ahead and bone this out now. So we can essentially loop through rows. So for row index in 0 to number of rows. This is another thing that has that same kind of pattern. So if row visible array row index, then do we want to do something? And for the first index on screen, we need to know if this is the first or top visible row that we hit. So I'm going to say var found equals false. And then in here I'm going to say if not found, found equals true, otherwise something else. So we need to actually assign first index on screen and last index on screen. Let's go ahead and start them both off at 0 in case we don't find anything. So in the not found case, e.g. our first one, we can just set first index on screen equals first cell index of this row index. And it might be our only one, so we also need to set last cell index on screen equals to last cell index of this row. Otherwise, we just need to set the last cell index equals the last cell index of row index. So when do we want to call refresh first and last cell index on screen? I'm going to go ahead and compress this. It's again going to be anytime any row becomes visible or invisible. So I'm going to go to this handle scroll content did change position, and I'm just going to say var should refresh first and last cell index on screen started at false. In the case that we freshly made a row visible, then we should refresh first and last cell index on screen. And same for the case where we freshly made a row not visible, should refresh first and last cell index on screen equals, again, true. Then at the very end, we only need to do this once, so if should refresh first and last cell index on screen, then refresh first and last cell index on screen. There's one other place where cells are becoming visible or invisible. And that is in hide all visible cells. So I'm again going to make var should refresh first and last cell index on screen equals false. If we do find a visible array, we're setting that visibility to false, so I'm going to say should refresh first and last cell index on screen equals true in that case. And then same thing, if should refresh first and last cell index on screen, then refresh first and last cell index on screen. So I'm going to go ahead and print these first and last indexes on screen. I'm going to say cell index. And this is going to be first cell index. And then let's just build and see if those numbers make sense, even through a scroll and a rotation. Okay, 0 to 17. That sounds about right. So as we scroll, it became 0 to 20, then 3 to 20, 3 to 23, 6 to 23. Yeah, that looks right. Then when I rotate, we're going from 14 to 34. And yeah, we computed that quite a lot of times. And it's going 0, 0 after we hide everything. So this is kind of zany while we rotate. So we're going to have to remember that it gets kind of nutty like that. But it's going to give us the correct result. So I'm going to kill that, kill this. Magnetic. We are on fire. So I'm going to go ahead and kill off this print statement. We don't need it anymore. But now we've got the tools we need to go into my page view model and fill in this fetch more thumbs if necessary. So the necessary thumbs that we want to fetch are of course going to be the thumbs that are on screen. So let's use what we just built. So let first cell index on screen equals layout dot first cell index on screen, and then let last cell index on screen equal layout dot last cell index on screen. And I'm just going to architect this loop. So I'm going to say var check index equal first cell index on screen. And then while check index is less than or equal to last cell index on screen, we're going to loop and we're going to increment check index. And what do we want to do? Ultimately, we're going to trigger a fetch if we find a missing model. But I also want to make sure we're in range. So if check index is greater than or equal to 0 and check index is less than, here's the tricky part, it's going to be model.total expected count, and this is to make sure we don't continually fetch past our range. We would essentially get into an infinite fetch loop. So then let's just make sure the model exists, and if it doesn't, let's go ahead and start a fetch. So if thumb model at check index is nil, let's go ahead and trigger that fetch. So fetch at check index with count. Of course, we have self.fetch count, and the completion is something we don't care about. Don't care in blah. While we're in the spirit of doing these sanity checks, let's just assume that fetch more thumbs if necessary could be called often. So what I'm going to do is say if is fetching return. But since we have that if is fetching return, I'm also going to put kind of a mirror case here in fetch complete success case. So I'm going to actually call fetch more thumbs if necessary in this case. So then is fetching will have gone back to false, and we're going to check it again and see if we should fetch again. So I'm going to call this case 1. Case 1 sells directly on screen. I really want case 2 and case 3 as well. So case 2 is going to be sells shortly after screen's range of indices. And case 3, I'm going to just copy and paste. It's going to be shortly before screen's range of indices. So in order to define this range, or just what shortly means, that's kind of a weasel word, I'm going to go straight to the top, and I'm going to say private static let probe ahead or behind range for prefetch. And this number should always be less than fetch count, because when you're going backwards, e.g. before your first index on screen, you don't want to go and fetch somewhere where it's going to create a gap. So these are both moderately tricky, not really. The third one is more tricky. So for case 2, shortly after screen, we're just going to start right after the visible cells. So last index on screen plus 1. And then I'm going to loop while check index is less than or equal to last cell index on screen plus this little probe ahead or behind range for prefetch. And then the body is going to be the same thing as the first one. For case 3, we're going backwards, but we don't want to loop backwards because then we're just going to be fetching one thumb at a time. So we want to make sure we start check index all the way backwards. So first cell index on screen minus, again, this probe ahead or behind range for prefetch. Then it's simply going to be while check index is less than first cell index on screen. You guessed it, the same body again. So I'm just going to copy that and paste it in there. One more not so much caveat, but very important thing is we could potentially be firing off a lot of fetches. So the goal of this function should just be to call either 1 or 0 fetches. So in all three of these cases, after fetch, I'm going to return. Alright, we're done. Let's run it and see. Cells coming in, cells coming in. Cool. So we should have fetched after our range. We got a few there. If we scroll to a random spot, it starts pulling in cells in that spot. How about that? Very cool. So I would pat yourself on the back. The goal is accomplished. This is beautiful, dynamic, user-driven prefetching. So again, you can check out the next tutorial. It's in the video description. Like, comment, share it with your friends, and have a wonderful day. Goodbye, friends.